Today we are going to synthesize phenylpropionic acid. Phenylpropionic acid is this guy, phenyl, and then there are 3 carbons with a triple bond in there. Propionic acid, according to IUPAC name, it should be phenylpropionic acid. Okay, so that's the synthesis. So you synthesized last week the Cinnamic acid. The Cinnamic acid that you used was specifically with a specific stereochemistry. This was a racemic mixture of this particularly erythro isomer of the cinnamic acid dibromide. Okay, when you see plus and minus, that means both 50-50 mixture of plus and minus enantiomers. You got basically a mixture, racemic mixture last week. So you'll be taking the racemic mixture and you will be actually treating it with the potassium hydroxide in the methanol solvent. And then, so potassium hydroxide is a very strong base. So very strong base, so going to pick up protons from this molecule twice. So in the first reaction, for example, the first reaction, it will pick up a proton from hydroxide, will pick up a proton from here, and it will become water, and it generates a negative ion. Negative ion comes over here, kicks out the bromide. So you get a double bond. So you have beta elimination reaction. First beta elimination reaction. You have actually 2 beta elimination reactions. Okay, this one, the first one. So the first one will give you from from single to double bond, and then you also hit it with another more of base hydroxide ion, which picks up a proton from here, and it eliminates the second molecule of HBr. So you get it from double to triple bond. So this is actually a double dehydrobromination reaction. Dehydro means hydrogen and bromination. Dehydrobromination. So 2 moles of HBr are eliminated. One thing that I want to point out to you that this is an anti-elimination reaction. Anti-fashion means hydrogen and bromine should be on the opposite sides. So you have to make it in a conformation that in which the hydrogen and bromine are in the opposite direction. Okay? Anti-fashion. So this is also anti-fashion, hydrogen and bromide are on the opposite side. So anyway, at the end of the reaction, you will be getting from single to triple bond after elimination of 2 hydrogen bromide molecules. So how do you basically do this reaction? You synthesized last week. Hopefully you have more than 2 grams last week, because last week reaction was bromination. It went in good yield. So you probably have more than 2 grams. Weigh out exactly 2 grams of your last week product and add, we will give you solution 25% potassium hydroxide in methanol. You add 4 ml of methanol solution in this, you make a mixture of it, right? Make a mixture of it in an evaporation disk. Yeah. People use ultramild flask, but I think a much better procedure that I found in 1942 paper in JACS. They use evaporation disk. The evaporation dish is a very good idea. So you actually take 2 grams of your substrate and add 4 ml of the base in it, and you start it to mix it, and after that you start heating it, slow heating, heat it till methanol is all gone. So you get a white stuff leaving behind, white stuff left behind. Okay, now you add 4 ml more of methanol. Now, not the potassium hydroxide, this time you add 4 ml of methanol. Previously you added 4 ml of potassium hydroxide solution in methanol. Now you are adding 4 ml of just methanol. And again dissolve it and again evaporate it. So you evaporate methanol twice. Okay? After second evaporation, your reaction is done. Now you basically turn off the heat and cool it down to room temperature, and after that you transfer this solid stuff into a Buchner funnel for vacuum filtration. Okay, so Buchner funnel, as you know, looks like this with holes in there. There's holes here. And you attach will go here, right? Excuse my drawing. And you put a little filter paper in there, filter paper, wet the filter paper with methanol, because you are going to actually wash it with methanol. Wet it with methanol, and after that you transfer this solid stuff. This solid stuff, by the way, is the potassium salt. Okay, you don't get propionic acid right away. Right now it is potassium salt. It's a salt, therefore it's soluble in water. Therefore you don't want to wash it with water, right? Right now, okay? So basically you wash it with a little bit of methanol in there, right? Now, after you methanol will get rid of a little bit of yellow stuff. Yellow stuff actually comes out of decarboxylated bromination. This is side reaction, you cannot stop it. And give you actually a nice smelling compound called hyacinth flavor. But you know, we are not. That's not the main product. That's a side reaction. So that's a yellow. So you need to wash it with wash this is a cake with yellow stuff. I'm sorry, the yellow stuff, and then wash it with methanol. Now methanol dissolves the byproduct over there and leaves behind only the salt. Now what you do is basically you actually add water slowly and dissolve it now, right? Because this will be a soluble one, right? Again, you keep it there, and then you just add water, and water will bring down your salt in it. So this will be salt of Cinnamic Dibromide. Plus just water, right? Alright, so you have actually a solution of cinnamic acid dibromide salt in water, and then all you got to do is you are here, it's the same stuff as here, and you add hydrochloric acid. So what you do is you protonate this oxygen negative over there. It's called acidification. So when you acidify it, oxygen gets protonated, so it becomes OH. This is neutral now. Neutral propionic acid is not that much soluble in water. Okay, so basically what you do is you collect this one here, and then you add hydrochloric acid to protonate it. However, it's a good idea actually to reduce the volume, because this is also an acid. So acid is slightly soluble in water. So you don't want to lose any yield. The best way is to reduce the amount of water in here. How can you reduce it? Just by evaporation. Evaporate some water to about, about 1/3 of the volume, and then you acidify it. Then you get more precipitate actually. Okay, you get better product by reducing the amount of water. Anyway, if you don't reduce water, you will still get some precipitate. When you get precipitate after acidification, then you do another filtration. Okay. Now this time you are interested in what is left behind as a residue in the filter paper, and you dry it. After drying, you basically you dry it or in the oven, or you leave it in the air for about 10-15 minutes, and leave it under vacuum for a long time. Also, that also helps, dry it and find out the percentage yield. All right, so let's get to the lab. In this experiment, I have used a modified procedure that I found in an article published in 1942 in the Journal of American Chemical Society. They reported a good yield of this product. So what I've done is I've taken an evaporation dish, and I have added 2 grams of the cinnamic acid dibromide that you made last week, and I added 8 milliliters of 25% potassium hydroxide solution in methanol, and then I have dissolved, I have stirred the mixture to get a solution, and then after that I evaporated the methanol almost completely on a hot plate. Then I have added 8 milliliters of methanol solvent, uh, and again I have stirred it with a glass rod to make a solution of it, and then I evaporated it again quickly on a hot plate. After that my reaction is done, and now I am going to do the workup. Remember, workup is the procedure by which you have completed the reaction and now you are trying to isolate the desired product, and so that will be the next step. So I have dissolved the solid stuff from the evaporation dish into 20 ml of water. Now water could dissolve it completely because the solid stuff was only in the form of ions. Carboxylate anion and potassium hydroxide, both are soluble in water. Now I'm going to acidify it. Remember, by acidification I'm going to protonate the carboxylate anion COOA, COO negative into COOH, and that's why you see over there as soon as I acidify it, you see a precipitate, because the product phenylpropanoic acid is not soluble in water, especially in cold water. So you can see I can keep doing it. I get more and more white precipitate, and I also shake it just to make sure that enough acid has not been added yet. So you should swirl it occasionally, and until you swirl it until you don't get any more precipitate. So still you can see that still I'm getting precipitate, and acidification process is not complete yet. So I will keep doing it until I get permanent precipitate that will not go away even after acidification. So it should be acidified pretty strongly acidic, maybe pH close to between 1 and 2, and I can actually check it with the pH paper. So now I have just want to make sure before filtration, I want to make sure that all the carboxylate anions have been protonated and it has been acidified. You can see pH paper tells me that it is strongly acidic. pH should be between 1 to 2, and now I'm ready to chill it again, and then after chilling in cold water, ice water mixture, then I get more precipitate, and now I'm ready to vacuum filter. So when you turn on the vacuum, and I'm going to pour it onto the Buchner funnel, and the Buchner funnel is fitted with the filter paper. That filter paper, by the way, is a part of the mass with the watch glass. So I'm filtering. I've already transferred most of it. Now I will get a little bit of rinse with water, and to get the rest of my stuff out. A little bit water, don't use too much water, because too much water is going to dissolve your product. So just a little bit rinse once or twice, small amounts of water, and transfer it again, and then you have to now leave it under vacuum for at least good 10 minutes, because it's water and it's going to take some time to dry it. So I'll see you in about 10 minutes. So my product has been on the under vacuum for more than 10 minutes, and after 10 minutes it may be still a little bit wet, but I think most of it is dry. And so now you can actually dislodge everything, dislodge the filter paper, which was a part of the mass of the watch glass, and transfer the solid stuff along with the filter paper onto the watch glass, and then reweigh it. After reweighing, you will know the mass of the product, because you already know the mass of the watch glass and the filter paper.